All right, we're in section 6.6 where we're going to use proportionality theorems. So there are a few theorems dealing with proportionality. We're going to look at them here on this first page of the notes, kind of get an idea of how they're used and by their definition and how they relate to um, different things when it comes to proportional either lines or proportional triangles, stuff like that, and even angles. So the very first one here, we have the triangle proportionality theorem, which states as a conditional statement that it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. So here we have our if-then statement, which means that if, in this case, TU, so TU is right here and QS is right there, if those two line segments are parallel, then they are saying that RT, which is right here, over TQ, which is here, is going to be proportional to RU, which is right there, over US, which is right here, which makes sense because since those two lines are parallel, they're saying like, okay, well, the two sides of the, in this case, larger line segment, it's not always going to be the larger line segment, but in this case, so where this vertex R is pointed, those two sides are going to be proportional to these two sides that are connected to those two parallel lines. Okay, so remember that's how it's set up with the use of this theorem. All right. The converse of this theorem states that, well, if these respected side or those line segments are in fact proportional, then we can say that they are those two lines are parallel. So another theorem that we have here, it says that if three parallel lines intersect two transversals, then they divide the transversals proportionally. So they're saying that UW, which is right here, over WY, which is right there, so it's on the same line. So it's being intersected by um, those three parallel lines, is going to be proportional to uh, Vx over xy. So if you look here, like these two lines are right there, these two line segments are right there, so that's how it's kind of set up um, as a proportion. And then this final theorem that we have here, it says that if a ray bisects an angle of a triangle, then it divides the opposite side into um, so it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So they're saying that AD, which is right here, over BD, which is right there. So it's the two lines that are intersected, is equal to, in this case, CA and CB. All right, they're not congruent. Probably shouldn't have wrote that way. So this, it would be like this over this is equal to this over that. So if you notice that AD and CA are on the same side of that bisected ray, and DB and CB are on the other side of the bisected ray. So keep that in mind. All right. So looking at these examples here, they want us to find the length of the segment. So in this case, they want us to find the segment of YZ, which is unknown. So I'm just going to call that X for right now. So because they're telling you that uh, WY and VZ are parallel lines, that means we can use that triangle proportionality theorem, the very first one. So if you were to reference the notes from page 1, we can then say, all right, well, we can say that, all right, so it would be like XW would be the top one, so that'd be 44 over WV, which is 35, is going to be proportional to XY, which is 36, over YZ, which is X. So by setting it up correctly, we can now just use cross products to figure out what the unknown is. So 44 times X is 44X. This is going to be equal to 36 times 35, which is 1260. Divide everything by 44. So X is about 28.64. So same idea, uh, same kind of an example. They want us to find MR. So again, I'll call that X. You're using the same theorem as we did up top. So to set this one up, it's going to be MR, which is X, over RP, which is 12, is going to be proportional to MS, which is 15, over SN, which is 20. So doing the cross products, I get 20x is equal to 12 times 15, which is 180. Divide that by 20. X is going to equal 9. So in these two examples, they want to know if the line segment PS, which is right here, is perpendicular to QR. So here, here, PS, there. Okay, so sorry for the inaccuracy of the lines, but you guys get the idea. So all you're going to do is you're going to set up the proportion and see if it's equal to each other. So in this case here, for this first example, it's going to be XP, which is 16, over PQ, which is 24. I got to see if it's proportional to XS, which is 20, over SR, which is 20. All right, so obviously right here I see that 20 divided by 20 is 1, and I know that 16 divided by 24 is not 1, but if you just multiply it out, 24 times 20 is 480, and 20 times 16 is 320. They're not proportional, so they are not parallel. So if I go over here to this second example, to set this one up, it's going to be, well, I want to see if 72 over 40 is going to be proportional to 90 over 50. 40 times 90 is 3,600, and 72 times 50 is 3,600. So they are the same. Yes, parallel. So I can say that PS is parallel to QR. All right, so this particular one is, all three of these examples are using the bisected ray. So in this particular instance, in order for us to determine what the value of the variable is x, we're going to use that last theorem to set up the proportion. So if you remember how it would be set up, in this particular instance, it's going to be QR over, in this case it would be RS, is going to be proportional to T, I'm sorry, PQ over PS. So if you look at the value of RS, that's our value for X. PQ we have as 7, and PS we have as 13. The one thing that's a little bit different is we need to find a value for QR. Well, there's nothing there, but what they tell us is QS is 15 right here. So in order to figure out what QR is, you're going to say that QR is 15 minus X. So when I do the cross products here, I get 7 times X, which is 7X, but here you're going to be 13 times it by the quantity of 15 minus X. So 7X is left as is. 13 times 15 is 195 minus 13X, so you got to distribute. In this case here, you add, I'm going to add 13X to both sides, so I get what, 20X is equal to 195, so divide that by 20. X is going to be 9.75. All right, so now looking at this one here, again, setting this up, it's going to be 12 over 8 is going to be proportional to X over 16. So do the cross products, I get 8X is equal to 12 times 16, which is 192, divide by 8, X is 24. Okay. All right, so now to look at this one, you know, it does seem a bit daunting just because, one, there's a lot of variables that you have to set up, and there's a lot of numbers that you have to look at. But in reality, um, taking one variable, like one step at a time is the easiest way to go about doing this. So first, in my opinion, I think the easiest one to find is Z. So Z is going to be set up as the proportion using, so I got Z over 21 is going to be proportional to 42 over 63. And looking at that, I'm going to say that, well, doing the cross products, I get 63Z is equal to 21 times 42, and that's what, 882, divide that by 63, Z equals 14. So this equals 14, all right? Now, when I look at the next value, you could say that the next value that I would go about solving would be the variable x. Reason why I'd go about solving that one is, if you notice, the distance from here to here is the same as the distance from here to here. They're both 42. So that means that if I have the distance from here to here being 36, that means that the distance for x is going to also be, I'm sorry, not 36, 63. The distance here is going to also be 63. And then all we got to do here is now fine, let's look at w. So now I can set this one up as say is w over 42 is going to be equal to, and in this case it's going to be 42 plus 42, which is 84 because it's this whole line segment here, so it's 84 over 63 plus 63 because we're dealing with this entire line segment, and that is 126. Do the cross products, I get 126W is equal to 84 times it by 42, which is 3528, and divide everything by 126, I get W equals 28. So W is 28. And the last variable I'm looking for is y. So now using that, I got to use this the largest triangle in this particular example to say, okay, I got 35 over 52.5 is going to be proportional to, in this case, it's going to be y plus 84, because you're dealing with this entire thing, because it's y plus 42 plus 42, over 31.5 plus 63 plus 63, which is 157.5. So now I do some cross products. So 157.5 times 35 is 55. 12.5 is equal to 52.5 times by the quantity of y plus 84. Leave the left side of the equation the same, distribute the right, so 5,512.5 is equal to 52.5y plus 52.5 times it by 84, which is 4,410. Subtract that 4,410, so 5,012.5 minus 4,410. I get 1,102.5, and that's going to be set equal to 52.5y. Divide 52.5y to everything. Y equals 21. Okay, so that is being able to use proportionality theorems. Again, uh, use those formulas on the first page. They're there to help you. Um, there, make sure it's consistent throughout the whole thing, and you should be just fine. I hope this helps. Until next time.